To begin the lesson, have students view the introductory video or read them the description of how Josh's scout leader told him about counting seconds to determine the distance from a storm. Ask the students how far away a storm would be if a scout counts 3 seconds between seeing lightning and hearing thunder. Prior research has shown that students will either approximate, for example, say somewhere about 2 miles, or set up a proportion, but not be able to explain why this works. Once several students have voiced a prediction, push the Animate Point button to illustrate the general idea that the sound of speed is traveling outward in all directions. Also establish the idea that, theoretically, sound travels at a constant rate, i.e., the circle's radius is increasing at a constant rate of 1 mile per 5 seconds. Also point out the running clock. Next, ask students how many miles the thunder will travel after 5 seconds. Click the Move for 5 seconds button. Click on the Show Table button and then double-click on the table to record this coordinate pair. Ask how it relates to the context, i.e., a person at location 1 is 1 mile from the storm center. Next, ask how many miles away a person would be if she counted 10 seconds. Once again, click on the Move Thunder to Location 2 button. Ask the students how far away the second tent is from the epicenter. You might want to hide the table to collect predictions before checking. For both of these questions, it's critical to require that students give conceptual explanations such as, since it took 15 seconds to get to location 2, then it took 3 sets of 5 seconds, so it must be 3 miles away from the center. Or, focus on unit measure. Every second, the thunder travels 1/5 of a mile. Therefore, in 15 seconds, the thunder has traveled 15 times 1/5 of a mile, which is 3 miles. This sets up a nice link to the slope as a constant of proportionality. As a check for understanding, ask the students to estimate how far away tent number 3 is. Then check with the table and add that point to the list of coordinate pairs. Ask if we were to run the animation without a specific location in mind and randomly added points to the table, what would each point represent? What do they all have in common? Then do this to add several more points to the table. Now, hide the map and show the axes. Ask students what the label for each axis should be. Click once on the table and then choose Plot Points. Make sure that the x-axis is time and the y-axis is distance. Ask students what they expect to see. Graph the line to connect the points. Ask what the slope of the line is. Remind them or ask them how slope is calculated and what units the slope represents. Use the slope triangles to illustrate how the ratio of the rise over the run for any 2 points remains the same. Ask them to predict if this will happen with other points that are not explicitly plotted on the line. Then, ask them what the ratio is. It should be 0.2. And how does this relate to 1/5? Remind them that the value of knowing the slope is that one can predict, for example, if the sound traveled at a constant rate, then a person 12 miles away from the storm would hear the thunder in how many seconds. Instructors may also want to point out the difference between a constant rate and an average rate, i.e., the average rate is the more realistic fact that the average speed of sound is not constant. It can be affected by temperature and other variables. So mathematicians speak of the average rate as the rate at which sound would have traveled if it had traveled the same distance in the same amount of time at that constant rate.